Now let's look at another example showing that two composite functions are equal. So if f of x equals 3x minus 4 and g of x equals 1/3 times x plus 4 in the parentheses, and then we would like to show f composed with g equals g composed of f. They're both equals x. So in order to prove this long equation, we just need to prove two short equation, which is f composed with g equals x and g composed with f also equals x. And then we can get this long equation. All right, so let's do that. So f composed with g, that means f of x is the outer function, g of x is the inner function, right? And then we plug in, we substitute g of x by its definition. So that's 1/3 times x plus 4 in the parentheses, right? This is a g of x. And then we plug in that to the outer function, 3x minus 4, right? Replace x by the inner function, which is g of x, 1/3 times x plus 4 in the parentheses. And then we simplify, right? 3 times 1/3, that's 1, right? So that's just x plus 4, and then minus 4, that's equals x. And then g composed with f, okay, we tried the other one. That's outer function g of x, inner function is f of x, right? And then substitute the inner function f of x by its definition. So that's g of 3x minus 4. And then plug in the outer function. G of x is 1/3 times x plus 4, right? Here it's supposed to be x, I leave it blank. And then now replace x by inner function 3x minus 4. And then we got a 1/3 times 3x minus 4 plus 4, that's just 3x, right? And then 3 and 1/3 cancel, that's why equals x. So since we got this two short equation true, that's why we can derive this long equation is also true. Okay, in the next section, okay, actually this is the way how we prove the two functions, their inverse function. That's the property. Okay, we just kind of preparing you for the next section. All right, that's the solution. And then the last subject in this section, we would like to do something backwards. So if we know two functions compose with each other and then equals the composite function, right? And given your composite function, and then we want to do the backwards, can we identify, what two functions compose together to get this function? Which is, in other words, given you h of x and ask you to derive what will be original f of x and g of x, so that f composed with g equals h of x. Okay, like a backward logic. So let's look at the example. Is if given you h of x equals x squared plus 1 raised to the 50th power. Okay, h of x equals x squared plus 1 raised to the 5th power. And then what is the original f of x? What is original g of x? So how to do this type of problem? You can find a major structure, look at the bigger picture of the function. We can consider this as a unit. So that will be something raised to the 50th power, right? So outer function is a bigger structure of the h of x. So that's x to the 50th power. And an inner function, it will be whatever in this parenthesis, okay, which is x squared plus 1. So when you know, f compose with g, which is replace x by g of x, and then we got h of x. Okay, that's one way to decompose it. Actually, there are many other ways to decompose it. Okay, for example, you can consider f of x equals x to the 25th power, and then g of x correspondingly, we just have to do x squared plus 1 raised to the second power. So f composed with g can get h of x. Okay, just manipulate the exponents. Make sure when these two multiply, we can get a 50. Okay, so other options can do f of x equals x to the 10th power, and then g of x can be x squared plus 1 raised to the 5th power, right? Because 10 times 5 got a 50. And then another way around, x to the 5th, and then g of x can do x squared plus 1 raised to the 10th power, and then 5 times 10, that's also equals 50. All right. So let's look at another example and then see if you are able to do this kind of problem. It says find the function f and g such that f composed of g equals h of x, and then giving you h of x equals 1 over x plus 1. Okay, so again, if you look at a bigger picture, okay, of this function, okay, which is you consider x plus 1 as a unit, and then the bigger function, f of x, it should be a reciprocal function. Okay, if you consider x plus 1 as an entire unit. So the bigger picture of the h of x, that's the outer function f of x, is reciprocal function. And then g of x will be replace x by x plus 1. Okay, so when you do f composed with g, you can get h of x. All right.